If we considered flooding in Nampa versus flooding in Antarctica, for example, flooding in Nampa is not too likely to happen unless, say, the irrigation canals are so full that nearby fields and houses experience flooding, or perhaps that the precipitation event is just too great. But if it got flooded, a lot of people and property would be harmed. So in Antarctica, as an opposite, the probability of flooding to happen could be quite high depending on the location that you're looking at within the whole continent, but the local consequences are very low since there are not many people or property there. So the risk would be rather low in Antarctica, despite the fact that the probability could be high. Okay, so more subjective than risk, which is again probability times consequence, is what we call acceptable risk. So acceptable risk varies from person to person, and it depends on the situation. An example outside the realm of natural hazards is skydiving, or another one could be getting into a car crash. So let's examine skydiving first. So if you skydive, then the consequences could be one of the highest, right? It could mean death if you go skydiving and you do it wrong. However, the probability of you dying from skydiving would be relatively low if you know what you're doing or you have done it previously and you know, or you go with somebody who knows how to do it, basically. So again, consequences could be highest, probability relatively low, so it would fall somewhere in this middle area of risk. However, you may have an acceptable risk that differs from your friend. So say that you think that the consequences, meaning death, are way too high because it does not just mean that you die, but it also puts a burden on your family and their financial stability, not to mention their emotional loss, etc. So you consider that this is simply not an acceptable risk, that the consequences are just way too high, and despite the probability as statistics being relatively low, you're just like, my acceptable risk is way too high, so I'm not going to do it. Okay? However, your friend may think that the consequences of his or her death are perhaps not that high. Perhaps this has to do with their belief system, or with their confidence in their ability and the current weather conditions. Who knows how they evaluate the consequences in this respect. So to them, skydiving would be an acceptable risk, again, because the consequences that they believe could happen if something went wrong, they don't think would be too high, and the probability, because of their ability, it decreases. So then they could think, okay, the risk in their case would be somewhere in the green to yellow area. So to them, skydiving is an acceptable risk. A car crash, on the other hand, is a lot more probable to occur based on statistics, and the consequences could be also the highest. They could mean death. However, most of us consider that driving is an acceptable risk because the benefits of driving and getting to places when you need to are so much greater than what we think the risk could be. So despite that overall possible risk, we still think it is acceptable. Of course, driving conditions may differ from place to place. Your vehicle may change, and so that might also change the overall risk that you have. The experience that you have may also be involved. The ability that you have, your awareness at the time when you're driving can change the probability and the consequences of getting into a car crash. So all of these are factors that you have to take into account, but all of those also change the perception that you have of what that risk or how acceptable that risk can be. So the same considerations take place when you are considering where to live, for example. So in the top image, we have an example of houses that have been built right on the edge of this cliff. In the edge of this cliff, as you're seeing from the image, you typically get a lot of coastal erosion. So if you choose to live here, perhaps you're choosing to do so because the views are too good. You will typically either not get insured, or you will have to pay for a pretty costly coastal erosion insurance. But ultimately, it is your choice. Later in the semester, as we'll take a closer look at specific examples in houses in Houston, you'll see that residents continue to go back despite the yearly flooding that they experience. Flooding, which again will cause expenses of more than the cost of their homes, basically, every single year. But because they are covered by government relief programs or because they are insured, they continue to go back to the same area despite the fact that they lose everything, basically. They get it back. Another example would be if you decide to live near a nuclear power plant. So the probability that there would be a meltdown of the nuclear plant is low, but the consequences could be very, very high. It could cause death, it could cause long-term damages to you and your family or your property, etc. So many people still choose to live near them, however, despite the probability or the consequences, being high. So many people choose to live near them, within miles, in fact, or even less. In my case, I would probably take this risk of living near a nuclear power plant if it meant that I have a much lesser commute, or I get to look or to be in a more green space overall, or a better home, or whatnot. So my acceptable risk for this scenario is much lower than my acceptable risk for the top picture. So I would rather live near a nuclear power plant than I would for a cliff house, if you would. So I would not take the risk of living in the top image, even if I had insurance, but I would take the risk of living in the lower image. But again, this is my personal opinion, and again, it is a very subjective risk assessment. It has to do with my own personal situation and decisions. Okay? So hopefully risk versus acceptable risk is clear. Alright, so the last subtopic that I'd like to cover for this chapter are the links between natural hazards and their physical environment. So here is where we would think of this concept of environmental unity. Okay, that's a very key concept. So in this concept, it is where natural processes, or if natural processes were to happen in a specific location, how would the physical environment in that location be affected? Not necessarily by human means or their property being affected necessarily, but how would the physical environment interact with said natural process that happened initially? So for example, let's look at Hurricane Katrina. So we know that Hurricane Katrina was a natural catastrophe for the city of New Orleans, and I believe that it was one of the costliest, if not the costliest, natural catastrophe that the U.S. had to recover from. So Hurricane Katrina, caused a lot of flooding, as you're seeing here in the image, which in itself is another type of hazard, right? So one hurricane being linked to flooding, that's two hazards already linked. So that would be an environmental unity of itself. So a natural hazard caused by another. If you think of Hurricane Katrina happening in an area of high topography, meaning an area with a high change in slopes, not in Louisiana where it did, the amount of water that fell due to that hurricane, along with the slope, that in this case would be, a high slope, could not only cause, again, the hurricane and then further flooding, but it could also cause landslides as a result of this. So that would be this hypothetical example where you have hurricane, lots of water, flooding, and then because of that flooding and oversaturation, you would get landslides after that. So that would be another example, and one that is carried even further for this environmental hazard unity, okay? Where you have several natural hazards linked. So this is just another diagram showing you that relationship, those links that can exist from one natural hazard to another. So another example, and in this case it will be here in Idaho, we know that Idaho sees a lot of wildfires occurring during the summer months, especially in July and August. After a wildfire occurs, the slopes that get burned tend to be weakened. as they are no longer full of vegetations to root the slope, right? So first of all, after the fire, there's a hydrophobic layer of soils that lies on the surface of the slopes. This hydrophobic layer makes any water that falls on the slopes to simply run downhill and not necessarily percolate through the soils, like infiltrating the shallow soils. So this lack of percolation causes flash floods as the water simply runs downhill, picking up any debris that might be on the slope, but not any soil, like not leaking through the soils, if you would. And this typically happens in the fall or early winter with an increase in precipitation that we see in Idaho. Second, with the flash floods further downhill, the oversaturation that the flash floods cause, it causes mudslides that can be so damaging that they can actually carry and rip off any vegetation that was left standing that didn't get burned. So with enough water, and if that water picked up things along the way, it can become a mudslide basically. This vegetation that is now dead, for example, can now serve as fuel for other wildfire in coming years. So again, the vegetation that got destroyed by the mudslide running through it is now dead, right, and left on the slope, so that in future years, if another wildfire were to occur, it could use that vegetation as fuel. So it will basically start the cycle all over again. So there's a link here between wildfires, the subsequent flash flooding, and the landslides that happen afterwards. And then again, the cycle continues over and over. So this would be in an immediate area where these three things are linked and continue to happen, for example. And it has nothing to do with human interaction, right? So now what I'd like you to do is think of other examples of environmental unity and of links between natural hazards aside from the ones that I just mentioned. So this is one of your assignments this week to give me examples of environmental unity. So you might as well jot down a few possible answers as you're listening through the video. Okay, so to wrap things up, let's go ahead and talk about how humans affect our natural hazards. So we've already talked about how an increase in population certainly can mean an increase in natural disasters. And that's because there are more people intersecting with natural processes, causing those to become hazards and potentially disasters. And we know that population distribution also has a large effect on who and how many people or property are affected by a natural hazard. So if more people live in a country that experiences more floods, for example, then those people would be more adversely affected by that natural hazard. And so depending on where you live, you may experience a certain type of natural hazard and a certain magnitude of that hazard from occurring. Also, one last thing that I'd like you to consider in this case is how us humans do affect the incidence, the frequency, and or the magnitude of natural hazard. So, as I mentioned in the carbon cycle, for example, when we were talking about the biogeochemical cycles, us humans burn fossil fuels for electricity production. And as we burn these, carbon dioxide that used to be locked up in the oil or the natural gas, so it used to be locked up within the lithosphere, is now being released into the atmosphere. As some of you know, or may be aware of, there is a correlation between carbon dioxide and temperature increase in our atmosphere, or decrease for that matter. So if carbon dioxide is higher, temperature is higher. If carbon dioxide is lower, temperatures are lower. And we'll get into that relationship when we look at climate change later this semester. But temperature increasing seems to affect many of the atmospheric natural processes' magnitudes. So us humans are able to influence to a certain degree the magnitude of some of the natural hazards from the use of some substances or some processes that we ourselves use in our daily lives.